When it comes to file management and automation, one of the major tools for Python programmers is the OS module. It is time-saving, very easy to use, and of course it's related to code. And in this video, we will show you two real-life beginner-friendly use cases of this OS module so that you too can use it in your own way when it's required. Let's get into it. Okay, so let's start by importing OS module, and then we will also need the shuttle module. We just use it for one functionality. The major focus is going to be on the OS module. Okay, so when you first have a look at this folder, we have 3 more folders inside this, and then I also have some Excel files which can be considered as CSV files, and then I have Python files followed by in between images as well. So what I want to do in this is I want to create a datasets folder and also an images for code folder, and both of these folders will contain the respective. For example, the dataset folder will contain all of the CSV files, and then all of the images will be put in the images folder. We can also do that for the Python files as well, but I'm just going to leave it for this case because when you segregate those two, Python files are the only thing that is left over in this folder. So let's create a main variable. I'm just going to keep this to be list. What other things are we going to create? First will be the datasets one. We're going to create the datasets folder, and then we will also create images folder. I'm just going to name this to be images for code, like that. And then now I will be creating the CSV file list. Now this list will contain all of the files that are of the CSV format so that we can get them into the CSV list and then we can store them in datasets in real action. So first I'm going to use list comprehensions for this. If you don't understand what that means, then we will walk you through that. So first let me just type in for F in os.list directory if F ends with .csv, like that. So what is happening here? When you actually look at os.list directory, this function will list all of the folders, file names, and images and everything that is present on the current directory where this code file itself is located. Now currently this osmodule.py code file is located in this folder. This is where all of our datasets and the images are contained. F will loop through that one by one, and then we're also checking if F ends with .csv file extension. So this way, if this string ends with .csv, that means that this is a CSV file, so that we can retrieve this and then put this into this list. Now I'm just going to similarly do that for the images as well. Create an empty list and then type in another list comprehension F for F in os.list directory, like that. And then this time type in if f.ends with. First I will check for some JPEG files, JPEG, and then I will also check in for PNG as well, .png. Just I'll put that in the next line. Again, so what is happening here? We're using the list directory function to get all of the files one by one, storing that in F, and checking if F ends with JPEG or PNG file. And if it is, we retrieve that and store that onto the images. Now that is done, what I'm going to do is first create these two folders, and we do that by first looping through the main list that we created. And then now we use the os.makeDirectories function, make directories like that, and type in M. So we want to create two folders, that is the datasets folder and the image folder. And then I'm just going to type in exist.ok equal to true. This basically checks if the file is existing, and if it exists, then it just does nothing. Okay, so let's just run up to this point. Let me just type in folders created. If it gets up to this point without showing an error, then the folders are created. It says folders created. Let's just have a quick look. And here we see the images for code and the datasets folder. Nice. Now we have to move all of the CSV files onto this and then put all of the images on the images for code folder. So the way we do this is again going to be very simple. We just type in for I in CSV, just get all of those one by one. And then now we will use the shuttle module. We will only be using this for this one functionality, that is to move I, that is the folder from CSV, that is the folder from the CSV list that we obtained. And then actually, before we do this, let me just show you the CSV folder itself. Print, actually we can just comment this out for now, because we already created the folders. So print CSV, let's just run that. And we see that we only have CSV files in here. So the list contains only CSV files. And now we're going to loop through this one by one by using for I in CSV and then we use the shuttle.move function. As I told you, we'll only be using this for this one functionality, that is to move the current existing location of this file to where do we want to move this. That will be main of 0, that is to the datasets folder. So we want to move the CSV file onto this dataset folder until all of the CSV files are moved. Let's just run that and see if it's working. But let me just print that success, just in case. Print. It says success. Let's just have a look. And now we see that we don't have any CSV file in this code folder, but then when we get into the datasets folder, we have all of them over here. Very nice. Now we're going to similarly do that for the images folder as well. Let me just close this. We can now comment this out and then now type in for I in images this time, getting all of the images one by one. Again, type in shuttle.move, then move I to main of 1, that is images for code, like that. Then again type in print done. Let's just run that and it says done. Let's just have a look at the folder, and now we see that we have no images in the code folder and all of them are moved to the images for code folder. Nice. So as I said earlier, I'm just going to leave all of the Python files as it is in this code folder. I'm not going to disturb that because that is the only thing that is left in this code directory other than the other folders. Okay, so this is the final code for this project. Now let's get to the second project. Okay, so first let's just comment this, and now I'm going to show you a real-time use case of this OS module, how I use this module to carry out a real-life image classification project. First, we acquired a dataset from Kaggle that says pizza and not pizza. This is my main modified folder, so I had to extract it once again to create another folder like this. You can ignore this, but when you actually download this, you will get it as pizza and not pizza. Now when you go inside it, you will see you have two different subfolders. One says pizza, which contains close to 1,000 images of only pizzas, and then the next subfolder that is not pizza, which has all the other food types other than pizza. And then you also see this Python file, which you can actually ignore. Now our objective is, when you actually go into this pizza not pizza folder, you should see three different subfolders: train, test, and validation, where the train folder should contain 70% of the original dataset, that is 70% of pizzas and 70% of not pizzas, and then test should contain 20% of it, and similarly for validation, which should contain 10%. When you go inside, you should see, again, it should divide into pizza and not pizza. When you click on pizza, you should see 70% of the original dataset itself, similarly for not pizza as well, and for the validation set and test set as well. Now for this project, we will need the random module, but again, our major focus is going to be on the OS module. So first, let's just create all of the main things that we will need. First is the main folder, which will be pizza and not pizza. And then we also have two different categories, that is pizza and not pizza once again. This time I will create a list saying pizza and not pizza, like that. Now also we will need the splits, that is train, test, and validation. So I'm going to create another list saying train, test, validation. And finally, we will also have to mention the split ratio, that is 70%, 20%, and 10%. So I'm going to do that in the decimal format because that is enough for the random module. It will be 0.7, 0.2, 0.1, like that. And that should be good. Now what I'm going to do is create a for loop to create train, test, and validation. So what I will do is for split, in splits, like that, I will create a split path, split underscore path will be. I'm going to use this function os.path.join and then type in main folder, the split that we just created. So what this does is it will create a path where the first initial one is going to be pizza not pizza. Let's just show you that, copy this and paste it over here. What actually happens is we will get a path like this, followed by a /, and then for the first one we will get train, and then since we're doing this 3 different times for train, test, and validation, we will get 3 different types like this, where the second subfolder is going to be train, test, and validation, and we will have to create all of this. So what I'm going to do is type in os.make directory once again, and then type in split path, which is what we just created, exist equal to true, like that. Let me just type and see if that is actually created folders, like that. Let's just run this and see. We see 3 different messages saying created folders 3 times. Now let's just go there. Now inside this we see that we have train, test, and validation. What I'm going to do next is the creation for categories folders. Let's just put a comma here like that, and we need to create 2 more folders, pizza and not pizza, inside train test and validation respectively. So what we do is again create a for loop, this time for the category, for category in categories, type in the category folder will be os.path join, you type in the split path, comma the category, that way just looping through 2 times, and we get this. Now we should make the directories respectively, os.make directories, category folder, comma exist OK equal to true, like that. Let's just type in and done. Now we see that we get 2 runs for each folder is created. Let's just have a look at the folder itself. We see that we have train test and validation. Now when we go inside this, we see pizza and not pizza, and similarly for the test set, and then for the validation set as well. Good. Now the next thing is to move all of the images to their respective places in the train test and validation locations. So what I will do is create another for loop, this time again for category and categories, like that. And then this time I'm going to create another category path, which will be os.path.join. Then you type in this time the main folder, comma the category. So why I'm doing this is the output will be such that there's something like this, like pizza, we would get something like this, and not pizza for that one as well. So we have to get all of the images that is present inside this path, and then we have to move them to their respective locations. So how are we going to do that? First, I will create image files and then do the list comprehension once again. Again, if you don't know what that is, you will understand as I type through. For F in os.list directory, I will mention the category path which we just created. If os.path.isFile, again type in os.path.join, category path, comma F. So what is happening? What is actually happening here? So when we type in F for F in os.list directory, again we know what is os.list directory, and then we mention the category path this time, that is the pizza not pizza, and then it will get into the pizza folder first, and then it will get into the not pizza folder next. So we get all of them one by one, storing that in F, and check if os.path.isFile, this function will check if a specific returned element is a file or not. In our case, an image is considered a file. So what we do here is first, given the category path, that is, let's say that the category path now is pizza not pizza pizza, and then inside the pizza folder we just got all of the pizza images and then storing that in F, and we're joining that over here and checking if that is a file. So if it is a file, then we store that onto the list that we created for the image files. So hopefully that made sense, but when you look at this code once again, or when you look at the explanations once again, you will understand it better. It's just basically checking if an image is a file, and if it is, then we store that in the image file. That's what we're doing here, but then we're doing that for all of the images in the pizza folder and then in the not pizza folder. Now what I'm going to do is loop over through all of these image files. Let me just type in image file in image files, and then type in the source path, that is the original path of the image, which will be os.path.join once again. Then type in the category path, comma the image file again. So we know what is the category path. Let's say for the first one it's going to be pizza not pizza, and then inside the pizza folder we're getting all of the image file names. That is, let me just show you. When we go here, when we type in pizza, this is the path that we created as category path, and these are the file names. That is, all of them are in numbers, and we store them in the image files, and then we're looping them through one by one, and we join that to create the source path. So when we look at this, this is the source path. The source path for the first image will be pizza not pizza inside pizza 2965. That is the source path, and we now have to move this to this respective location, and we now have to move this to the respective location. So now I'm going to determine the split ratio. So let's create a random number as random.random. This will generate a number between 0 and 1. Now I will check if this random number is less than split ratio of 1. Split ratio is 0, that is 0.7 that we created over here. So if it's less than 0.7, that means that the file should belong to the train folder. So destination file folder will be train. Let's just do that for the test set as well. Split ratios 1. That means that this will go into, actually let's just add in the split ratio 0 as well. We're doing this because we want the numbers between 0.7 and 0.9 to go into the test folder. Test. So this will be 0.9. Let me just comment that. 0.7 to 0.9, less than 0.7. And then for the final one, that is for the validation set, and a number will be less than. Actually, we don't need to do this. And then for the final one, we can just type in else. Destination folder will be validation, like that, and this is for the rest. 0.9, 0.9 to 1. Now we have the destination folder. What we do next is create another destination path. Create the original destination path this time. Destination path will be os.path.join once again. First type in the main folder, that is pizza.pizza, and then we will type in the destination folder, that is, it is either train test or the validation, and then inside that we will mention the category, that is whether it is a pizza file or a not pizza file, like that. So that will be our destination folder. Now we can use the shuttle.move function. Shuttle.move, we move the image from the source path to the destination path, like that. I will see here we move the image from the source path to the destination path. Then let's just come out and see if that worked. Print data split and folders created successfully. I just see that we have to print elif here, like that. Now let's run our code and see, and we get this message, data split and folders created successfully. Let's just get to the folders and see if it's working. We see that the pizza and not pizza folders are completely empty. Let's get to the training set, and we have pizza and not pizza. We see all of the pizza images, that is 70% of the entire pizza images are inside this folder. And then when you get to the train once again and look at the not pizza ones, we get all of the not pizza images over here. Let's just get to the validation one and make sure that's also working. We see all of the pizza images here, and these are all of the not pizza ones, like that. And then similarly for test set as well, and we see that we have all of the pizza images and then the not pizza images, like that. Now all we can do is we can delete these two folders and leave it as it is. So this is the modified pizza not pizza folder that I have over here as well. This was the one that I originally did before recording, and we see that we also have pizza images over here, just like we had for that folder. So overall, the things you will most often use are this directory function, and then the path.join function, followed by the make directories function, and of course the shuttle.move function. Now, just like the OS module, there is NumPy module, which single-handedly takes care of the linear algebra and math in machine learning. And we have a video showcasing the top 10 functions of NumPy. It is linked right here.